All right, you guys, so for the most part on these problems, I'm going to help you set them up. I'm not going to plug in the data into the calculator because Alex will catch you on that. And I think it's the least important thing that we are going to do. The most important thing is being able to understand how to use this. So at the end of the last video, I started to show you how you're going to be using the ratios to find unknowns. Okay, unknown sides, or even unknown angles eventually. But at the very beginning, it's unknown sides. So what you do, here's your strategy. You stand, okay, here. You stand where the angle they give you, at the angle that they give you, and you identify your sides. Okay, so we have this kite, it's flying in the air, it has an 80-foot string. So there you go. Okay, right away you recognize that no matter where you stand, that's the hypotenuse. And the string is pulled taut. The angle of elevation of the kite is 63. Find the height. So this is the side we're looking for. Okay, round your answer to the nearest tenth. Always pay attention to that. But here we go. You stand here. This is the strategy. Identify your sides that are involved in the story. This one is called the opposite. That one's the hypotenuse. Okay, always go back to SOHCAHTOA. Sine is the opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. This is just a little way to remember it. Sine is opposite over hypotenuse. That's what we have. We have opposite and the hypotenuse. So set it up. Formula, right? Sine of, by the way, I could actually make you do formula substitution resolution like this. Opposite over hypotenuse. And then rewrite it as sine of 63 is equal to the opposite, which we don't know. I'm going to go ahead and call this x because we love working with x, over 80. And now all you have to do is solve for x. Multiply by 80 to get rid of the denominator and plug this into the calculators. So it'd be 80 times word sine 63 equals. Okay. And that's it. That's it. Man, trig is a beautiful thing. What's cool about trig is that you really only need, if you have a right triangle, you only need two pieces of information and you can solve the entire triangle. You can name every single angle and every single side. So now here comes the next level. You guys, the next level is being able to find the angle. And for that, it's going to be a little, you're going to have to remember, I feel like, okay, you don't have to remember anything, but we are going to have to undo a sign, and I'll show you what that means in a second. So here you go. Same strategy. Stand here. Okay, what sides am I given? I'm given adjacent and I'm given hypotenuse. Which ratio deals with adjacent and hypotenuse? And the answer is cosine. You can always go back to SOHCAHTOA, adjacent over hypotenuse. So we're going to say the cosine of x. Now look, our x, we're solving for an angle. We don't know what the angles are. So we got to find one. And that's going to be equal to 16 over, and I can't read because I wrote the word hypotenuse over it, over 20. Look at that, and I can't even erase it, can I? No, I didn't lock it down. Let me lock this down, guys. Oh, no. I can't lock it down either because, well, I'll lock it down for the future, but that's 20. Okay, so I wouldn't be able to erase it now because I just locked it down. Okay, 16 over 20. And so it says to the 10th of a degree. So here's the thing. We know what the cosine of x is. It's 16 over 20, but we're not asking for the cosine of x. We want x. You can't divide by the word cosine because that's not a thing. That's like dividing by addition. That makes no sense. Okay, it's telling you that the ratio is equal to this. So you have to undo cosine. Okay, so to undo it, you use this. Okay, these two, that is the inverse. Okay, that is the inverse cosine. Inverse cosine, and it undoes cosine, or in other words, it goes from cosine to the angle. In other words, we go from the cosine ratio to the angle. So if I do it to this side, I must do it to this side. So I'm going to need to take the cosine inverse of this quantity. These two will cancel each other out, and you get x is equal to the cosine inverse of 16 over 20. And I am going to go over there to Decimal Scientific for this one, okay? 16 over 20, which of course is 4/5, but I don't really care about that right now. So we're going to go to functions, and you'll see it, it's right here. We're going to go cosine inverse of 16 divided by, and there you go, 36.9, because it says round to the nearest tenth. So 36.9. So the angle is going to be x is equal to 36.9 degrees. And that is the answer. Remember, okay, the angle is not going to be this teeny tiny ratio unless it, it just wouldn't typically be. You need to go, okay, wait a minute, I don't want the cosine, I want the angle. Let's try the next problem. Okay, by the way, the word problems with triangles, don't be scared of the words. Just look at the triangle in the picture. To be honest, the words just explain what you're dealing with, but you don't even have to know. You just need to look at the triangle. So this is a ladder. It's against a house. Who cares? Okay, the bottom of the ladder is 8 feet. Okay, find x. So again, we're looking for x, and we're going to be standing right here. So what sides do we have? We have adjacent, and we have hypotenuse. But what do we want? Okay, it says, oh no, we want x. Find the elevation of the ladder. Okay, sounds good. All right. If they had wanted the height of the building, we could have used the Pythagorean theorem. You guys see that? 8 squared plus b squared equals c squared. But they didn't want that. They want x. Okay, so again, they have adjacent over hypotenuse. So that is cosine. So cosine of x is equal to 8 over 15. To undo it, we take the cosine inverse of both sides. And that's going to leave us with x is equal to the cosine inverse of 8 over 15. And that's it. So to go from the angle, to undo, basically to go from the angle to the angle to, from the ratio to the angle, you use this cosine inverse. Next, solving a right triangle. You guys, you better believe I'm going to make you do this as a quiz. Absolutely. This is critical. This is like a big test in geometry, but for you guys, it should be a repeat, and it shouldn't be that hard at this point. Solving a right triangle means to find all angles and to find all sides. Find all angles, find all sides. All right, so we can't use the Pythagorean theorem. That's what I always check first because I like it. And you can't use it because I only have one side. I have one side and one angle. Well, okay, what can I do? I can choose. I can choose to pick what I want to do. I got to stand here because it's, well, actually, I don't have to stand here. I can figure out what this angle is. It's 40 degrees because these two add up to 90 because all of the angles add up to 180. And I'm going to write that 40 better so it doesn't look like a 48. Okay, 40 degrees, right? All right, so we got 40 degrees. So here we go. We can either stand at B or we can stand here at A. They didn't label A and C. I don't know why they did that. Maybe they wanted you to stand at B. I don't know. So I think I must have cut off things on this one. So you would do angle B is equal to 40 degrees. I'm sure that's how you'll have to put it into Alex. So now we've got all our angles. Check. Doesn't mean it's always going to go in this order, by the way. All right. So let's stand at A or B. I'm going to stand at B. Okay. And what side is the only known side? It's my opposite from B. This is opposite of B. And let's find A. This is adjacent. adjacent of B, right? So let's find that adjacent and opposite. Which ratio works with adjacent and opposite? And that is tangent. Tangent is equal to the opposite over adjacent, right? So I'm going to take the tangent of 40, because I know what it is equal to 19 over A, which is adjacent. Multiply by A, divide by tangent of 40, both sides by the tangent of 40, right? And I'm going to get, I don't think I should do that, you guys. I think I should show you the work, because I know that I confuse people when I take too many steps. There. Divide both sides by tangent of 40. You have to divide by the whole word, guys, because that's an actual thing. So A is going to be equal to something. 19 divided by the tangent of 40. I'm going to go ahead and find that out. 19 divided by the tangent of 40. Let's do this. Okay, so 19 divided by tangent of 40. And it's 22.64. I'm going to go to the 100th because I don't know what they asked for. So let me go back. Is it the nearest 10th? 10th. Okay. What was it again? Geez, memory of a fish. 22.6. Okay. So this is 22.6. Well, now we have a side. Okay. All we need to find is the third side. So you have a choice. You can either use trig or you can use the Pythagorean theorem. If you choose to use the Pythagorean theorem, it would look like this. 19 squared plus 22.6 squared is equal to c squared. And then you square that and you square that and you add them together and you take the square root. So let's do this. 19 squared plus 22.6 squared. Okay. 19 squared plus 22.6 squared. And that is equal to 871.76. Okay, so I could write that. I could write 871 point whatever is equal to c squared. And then to solve for c, I have to take the square root. So I'm going to take all of this, and I need to take the square root of it. So I'm going to move my cursor back to the beginning, and I'm going to hit square root. Well, that didn't work. So since that didn't work, I'm going to do a trick. You guys, if you remember, the cool thing about having knowing fractions, do you remember the square root is to the, the square root is to the 0.5, is to the power of 1/2, to the 0.5. It's 29.5, but you can just enter it into your calculator. I just like doing that because I can. Okay, so it's 29.5 rather, 29.5. Boom. So C is going to be equal to 29.5, and I have now solved this triangle. Okay, some of you guys might prefer to use a trig function instead. So in other words, maybe I wanted to do, let's see, how about sine? Sine of 40 is equal to the opposite 19 over hypotenuse to find the hypotenuse. Maybe instead of the Pythagorean, you're like, ooh, I'd rather use trig. So multiply by h, divide by sine 40. So h is equal to 19 divided by sine of 40. And check it out. If we go to Desmos, and we go to Desmos and we put 19 divided by sine 40, divided by sine of 40. You get 29.5. Okay, you get 29.6 when I round it off, and that's an important thing. Okay, 29.6. Notice that using the Pythagorean theorem, I got 29.5. This one, I got 29.6. These discrepancies, like if I were giving a test, normally don't matter. So I don't know how Alex is going to do it. You might want to check and see if they don't like the Pythagorean, then you might need to use this. Because they're asking you to round it to the nearest tenth, it can always be off by 0.1 depending on what it can be. Can't really be off by too much more than that. Okay. And Alex might even know that and might let it and might be okay with this, by the way. Okay. All right. Next. Okay. It's given you two triangles now. Oh my God, can you handle two triangles? Yes, you can. Because this side right here is equal to 19. So you have two triangles. If you need to, redraw them outside. Okay. But first, let's figure out what they want. David sitting in a movie theater, 19 meters away from the screen. The angle of elevation, by the way, the angle of elevation means like this, like how far that. This is the angle of elevation. Okay. The angle of something, the opposite thing is like if you were flying and you were looking down. And these two, because this is parallel lines cut by a transversal, are congruent anyway. Okay. So angle of elevation, here it is right here. Boom. Okay. From his line of sight is 15. So basically they're just telling you what the picture says. Angle of depression, that's it, depression. This is elevation and depression. In this case, they're not congruent because they're not cut by it's not two parallel lines cut by a transversal, okay? This is a different situation. All right, angle of depression is 22. Find the height of the entire screen, okay? So in other words, they want this whole thing. Well, we don't have a right triangle for the whole triangle, you guys. We only have two little ones. So what they're really asking us to do is to take out these triangles. Wait, I'll do it the other way. Okay. Take out these triangles. This is 22. This is 15. Okay, this is 19, and this is 19. So now we have two. And what we need to find is both this side and add them up. That's what it is. We're adding this side plus this side. Okay, so we're going to stand here and we're going to see what relationship do we have. We have adjacent, this is adjacent, and this is opposite. And here we have, oh look, adjacent over opposite. So we're going to be using tangent because tangent is equal to opposite over adjacent. So first we're going to do problem one is let's do the smaller triangle. Tangent of 15 is equal to 19 over x. I'm going to call this x and I'll call this y. And then we're going to say tangent of 22 is equal to 19 over y. And then of course you multiply, or if you are like me and you love doing this, do that too. It's the same. X tan 15 equals 19. Divide both sides by tangent of 15. Tangent of 15, sorry. And so you plug that into your calculator and you'll get the answer. And here, if you just remember, you can flip it around. 19 over tan 22. Yeah. You guys also know there's another cool way to do this. Look, if you have the tangent of 22 over 1 is equal to 19 over y, you can flip both of these fractions. Did you know that? You can do that. You can flip them both. And then all you have to do is multiply both sides by 19, not by 15. Let's try that again. By 19. And then you get the same answer, 19 divided by 22. See? It's kind of a fun way to do it. Next. Okay, it says find the lengths of side B and C. All right, so here we are back to solving. Oh no, these are special right triangles. I included these just to help you because on tests, they kind of expect you to know this. And if you know it, you are at such an advantage and you can cut out serious time. So here are the special triangles. There are two. The first one is 30, 60, 90. I apologize for that. That is uncomfortable. Let's try this again. 30, 60, 90. So this is 30. This is 60. This is called a 30, 60, 90 triangle. And here's the way it works. If this side is x, okay, whatever length this is, the hypotenuse is twice that. And this side is root 3 times x times root 3 divided by 2. Or is it just x divided by 2? Hang on a second. It's root 3 divided by 2. Because that's 1/2 x. Wait, sorry, you guys, I need to think this through. You know what? It's so funny to think this through. I'm going to actually use something that you're going to learn in trig when you get there. This is 1/2, and this is square root of 3 over 2. Which means that if this is x, that's going to be twice that, because twice of 1/2 is 2x. Oh, it's root 3x. That's why. That's what I knew. I had something wrong. Oops. Okay, sorry. I knew I had something wrong. Okay, this one is going to be x times root 3. Okay, I knew it wasn't divided by 2. All right, so you don't need to know this. This is me just figuring out. It's more, I wish I could teach this to you this year, but I can't. Okay, so this is a key. Think of this as a key for all 30, 60, 90. So in other words, the cool thing about this is that if they just give you one side, you can literally figure out everything else. Okay, so in other words, take a look. This is a 30, 60, 90. Okay, they've given you one side. That is it. But they gave you the long side. Oh, well, I picked kind of a hard one. Let me pick an easier one. This one, it's not hard, but it's not easy, okay? Let me pick a better one. So let's say I give you a 30, 60, 90. I'm just telling you, this is 30, this is 60. Okay, make the association. This is going to be the short side, this is x. Okay, the side that's the hypotenuse is 2x, and this is x root 3. Okay, all I did was change the orientation. Okay, so now let's say I give you a triangle, and it's 30, 60, 90. Okay, and it's oriented like this. Okay, and I tell you that the short side is 5. Okay, well, guess what? If we know that x is equal to 5, right? We know that this side is 10 because it's twice x. That's what it says. And this side is 5 root 3. That's what it is. And let me show you why this ends up being 5 root 3. Because a squared plus b squared equals c squared. Let's say we knew these two. 5 squared plus b squared equals 10 squared. That's 25 plus b squared equals 100. And then you end up getting, let me shrink this down a little, move it up. You end up getting b squared is equal to 75. So b is equal to the square root of 75. You can break this up into 25 times 3. See, 5 root 3, and there it is. Okay, this is just proof. I'm just showing you proof. Okay, I wish I could show you all the proof. It's frustrating teaching this in a really fast way without actually explaining all of the things. All right, so for example, if I gave you another 30-60 triangle like this, and I told you this was the 30, and it was right, you know that this side is the short side. And I told you this side was, let's say this side was 20. I would know that this side is 10 because it's half, and I would know this side is 10 root 3. Okay, so you get the idea. It's a key. It's a code. It's so cool. It's giving you the key to solve this, okay? But what they did this time is they gave us the long side. This is the harder problem. So what you do is you use the key. 6 is equal to x root 3. And then you guys are smart enough to solve for x. You just divide both sides by root 3. And then you go, alarm bells are sounding because you can't have a radical in the denominator, so you must multiply by root 3 over root 3. So you get 6 root 3 over root 3 times root 3 is 3, right? Root 9 is 3. And then you can simplify, and you get 2 root 3. Okay? And now we know that x is equal to 2 root 3. That means that b in this example is equal to 2 root 3. Okay, x is equal to b. It's right here. Okay, and then if b is 2 root 3, this side is twice that. So it's 4 root 3. It's twice 2 root 3. Okay, so that's really cool. That's special triangles. I am going to go ahead and move this over a little. Well, I thought I was. Let's try getting this here. I'm going to move this over, and I'm going to show you the 45, 45, 90. That's the other key that you have to know. Let me get a different color. Okay, let's do 45, 40, 45. Did they say 45, 90, 45? I think they say 45, 45, 90. Okay, so this is the triangle that looks like this. It's, first of all, these are equal. It's 45, 45. These are congruent. This is your hypotenuse, remember? Okay. And here's your key. Your key is this, is that if this is x, and this is going to be, oh God, I forgot. Sometimes I forget. X squared plus x squared is equal to c squared. So you get 2x squared is equal to c squared. And so divide, we're trying to find c. It's the square root of both sides. So it's x root 2. That's right. Hypotenuse is x root 2. That's your code. So that, look here, they gave you 5. Well, that means this is 5, and it means this is 5 root 2. It's that simple. The harder problem would be is if I gave you an example and I gave you the hypotenuse was equal to 10. Okay, using the key, you would have to set 10 is equal to x root 2 to try to find what x is. So I would divide by 2, root 2, and then I'd be like, crap, I can't have that. I must multiply by root 2 over 2 to get rid of the radical. Okay, and then I get 10 root 2 over 2, and it cancels and you get 5. Huh. Oops. Did I literally just do the problem that we had? No, I didn't. Okay, so x would be, this would be 5 root 2. Do you see how that's cool? Do you guys see how that's x? Because look, in there it says x times root 2 is equal to 10. So 5 root 2 times root 2. Root 2 times root 2 is 2. 5 times 2 is 10. See how cool that is? All right, I think this is the next one is the last problem. Let me see. Let me make sure. Yeah. Okay. All right. It says for the right triangles, find the exact values. Okay. Exact means do not put it in a calculator. Okay. That means leave it in simplified radical form. That's what I did in the problem. So using the key, and you guys should have it, use your key, write it down. This is congruent to that, and this is 4 root 2, and that's your answer. This 7 is equal to x root 3. So you do the math. 7 is equal to x root 3. Divide by root 3, divide by root 3. Cancels. Multiply by root 3 over root 3 so that you get rid of it, and you get 7 root 3 over 3. And that's the answer. Okay, that is x. That's this one right here. That's b. Okay, that's the shorter side. 7 root 3 over 3. And this is twice that. So it's 14 root 3 over 3. Okay, next. Okay. Now, wait, didn't I already do this problem? Three. Opposite over adjacent. I think I accidentally put this in here. I think you're fine. So this would be tangent. Tangent of 63 is equal to 7 over x. Yeah? All right. I think that's good for this one.